Assalamualaikum warahmatullahi wabarakatuh. My name is Farhana Islamia. Today I'm going to present you the drum dryer. So drum dryer is a method used to dry all liquids from raw materials with a drying drum. Also known as rotary dryer, is an energy-saving and high-efficient drying equipment. It also comes with thermocouples on the feeding and discharging device to control the temperature. So the working principle of the drum dryer. Two identical drums are installed next to each other and the material is fed from the top into the gap between the drums. A thin layer of molten feed forms on the outside surface of the rotating drums. The inner surface of the drums are heated with steam or hot water. This results in heating of the drum and remove the excess moisture from the molten feed, which after scraping result in a dry powdery product. The material dried through a chute head of the drum can be controlled through a VFD. The capacity of the dryer depends on the material of the product, the temperature of the product, the heat level of the drum in the molten feed, and by the temperature of the drying drum. So, environmental effect on drum dryer. First, higher energy use and higher cost of capital inputs such as loading and unloading the heat slab. Next, global warming potential of the biomass drying process. The safety precautions while using drum dryer. First, keep operating personnel from getting into dangerous areas or unsafe positions, especially while the dryer is operating. If unsafe conditions cease, the dryer must be shut down until the condition is corrected. Next, etiquette barriers, footwalk platforms, and signs should be installed at appropriate locations to protect and warn personnel of the potential hazard. Third, carefully instructed on the proper use of equipment and potential dangers of the steam system, high pressure and high temperature associated with dryer operation. Last but not least, recommend that a trained and responsible person be designated at each mill to oversee safe operation, maintenance, and inspection programs for dryers. So this is the P&ID drawing of drum dryer process. So type of controller that I use is a feedback cascade control. Why I choose feedback cascade control? It is to prevent inner loop disturbance from affecting the outer loop, and the controller responds quickly to high frequency changes. Cascade control also reduces the effect of specific type disturbance. So the manipulated variable, in order to keep the level constant as the output demand changes. In my equipment, the manipulated variable is water flow rate. Next, control variable. The control variable of my equipment is temperature and pressure of the drum dryer. It is controlled in order to reach the system output. Next, disturbance. A water signal that tends to affect the output value. So what to control? So I will choose to control temperature. Why? Because the working principle is drying and it uses temperature as the main basis in the process, and each process requires a controlled temperature in order to reach a set point. So last but not least, conversion P&ID diagram. So this is the overall schematic diagram of a drum dryer. The drum dry consists of rotating drum, cyclone, and condenser. So the main equipment is controlled by its control panel. There are two control valves. The first one is valve controlling water inlet to the condenser. The second one is to control air pressure inside the cyclone to collect dust. Next, the raw material will be fed into the feeder or hopper. Inside the rotating drum, the wet material indirectly gets heat from the hot air channeled by the heat. Each equipment, their temperature is always observed so that there is no sudden rise or fall in order to reach the set point. In order to avoid disturbance, the heater is controlled and cooled by the condenser, and the condenser uses water as their cooling agent. The indicator can be easily controlled to meet user's requirement. So the rotating drum dryer is specially designed rising plate to minimize heat transfer between material and hot air. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aziza Ain Azila bint Abdul Ghani. So, I choose evaporator equipment in this plant. Okay, evaporator is absorb heat from surrounding. It turn the liquid feed to vapor product through evaporation. I decide to choose plate evaporator because it easy to disassemble, inspect and clean. On processed liquid, it also can achieve higher heat transfer coefficient. The important reason is it lower installation cost. So we proceed to the evaporation process. In this process, it uses triple effect evaporation. It can concentrate dilute solution and less energy use, so it is effective way to use. In triple effect evaporation, it uses water vapor as heating medium at lower boiling point. Latent heat in a water vapor can reuse by thermal compressing to high temperature. The advantage of use triple effect is it can improve efficiency. We can relate the environment issue from this evaporation process. For example, when treat waste stream with the standard evaporator, it can cost for equipment, which the results show the lower rates of heat transfer and efficiency. So evaporator need regular cleaning to reduce evaporating efficiency. So I suggest to use heat exchanger in evaporator as a safety way to overcome this environment issue, which is use corrugated tube exchanger such as K series or scrape surface heat exchanger, because it can guarantee falling free operation in large capacity installation.
Okay, we go to the process evaporation in 3 filter evaporation in evaporator. So, feed from the distillation column. Go to the first evaporator. Here we have valve, pump and valve to control the flow. Go into the evaporator. Stream here. Also go to the first evaporator, and we have equipment pump and valve here. Every evaporator also have temperature control, temperature transmitter and temperature indicator. Every evaporator also have heater here. So the flow go to the second evaporator that have pump and also valve, and the same control is here. So we go at third evaporator and also have the same here, also here and here. Okay, at third evaporator we have two outlet. The second one go to the drum dryer and another one to the condenser. Here also we have pump and valve. So this is the 3 filter evaporation in 3 evaporator.
Okay, next, I choose a feedback and feed-forward controller because it can improve performance over simple control. Feedback control can track set point changes, and feed-forward can measure and control the disturbance. So here the manipulated variable, which is MV, is used in the control system to adjust to achieve system goals despite disturbance with high MV to get a fast response in process. Then, process variable is used to filter evaporation, which is in evaporator we consider the material selection such as stainless steel, metal alloy or graphite. Okay, for the control variable, I choose the control temperature, which is used 428 to 823 Kelvin in the process. At high temperature, the droplets exhibit the expansion and shrinkage phenomena due to bubble formation and rupture. Strong puffing is observed at 823 Kelvin, and the process will be the same as the set point. The control objective is to maintain the value of temperature. Temperature sensor will be used to stabilize the chief. We also include the safety feature, which is a thermal runaway, so it maintains temperature out at set point by manipulating state. Before that, I need to talk detail about a controller, which is feedback controller can maintain temperature out with adjust the valve, and the feed-forward controller can measure inlet flow rate, adjust steam flow rate, and also control temperature out. Last but not least, disturbance variable give effect to the process and output value. It causes deviation from the set point, but we can solve it. We use the feedback and the feed-forward controller using every equipment to make sure the process will run smoothly. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Fatihah binti Ghani. The main equipment in acetone-butanol production that I choose is a mixer. The mixer that we use in this process is continuous stirrer tank reactor. A continuous stirrer tank reactor is a batch reactor equipped with an impeller or other mixing device to produce efficient mixing. Continuous stirrer tank reactor are open system where material is free to enter or exit the system that operate on a steady state basis where the condition in the reactor don't change with time. Reactants are continuously introduced into the reactor while products are continuously removed. Working principle of CSTR is reactants and products are continuously added and withdrawn. In practice, mechanical or hydraulic agitation is required to achieve uniform composition and temperature, a choice strongly influenced by process consideration. Next is safety precaution. When handling this equipment, you must wear proper breathing apparatus when working on, in or around tanks with toxic fumes. Test atmosphere before entering tank. Second is do check carefully all the equipment. Tools or bolts left unmoving part can fly off and cause serious injury. Third is use interlock guard to prevent access to moving parts. If the process in the mixer can work properly, it can cause environmental effect and also can cause serious injury. First is explosion due to overpressure. This occurs when runaway of exothermic chemical reaction and also improper venting due to corrosion or chemical damage. Second is release of toxic, flammable, carcinogenic material. Third is release of high temperature material. In the mixer, the variable that we want control is temperature because the temperature needs to be maintained at a specific value so that the process can run smoothly. The control objective is to maintain the temperature of outcoming liquid at the desired value or set point by manipulating coolant flow rate. The manipulated variable is coolant flow rate, and the disturbance in this process is first is feed temperature and second is flow rate of liquid. To prevent the disturbance and reach the set point, we choose the cascade controller to solve the problem. Cascade control can improve the process performance by reducing disturbance through the use of thermocouple control. It is because cascade controller responds more quickly and effective to the disturbance. The inner loop is both faster than the outer loop and closer to the source of the disturbance. This allows for a quicker reaction of upset in the process. Cascade control also can reduce the effect of dead time or phase lag time in the system. So this is a control scheme of PNID diagram. The reactor needs to be cooled during continuous feed operation of an exothermic reaction. The reactor has been equipped with a coolant water jacket with the water flow rate being controlled by cooled water valve. This valve is controlled by two separate temperature controllers. The first one is inner loop or slave. Temperature transmitter communicates to the slave controller the measurement of the temperature of the jacket. And the second one is outer loop or master, which is the temperature controller use a master temperature transmitter to measure the temperature of the product within the reactor. A temperature controller manipulates the coolant flow rate in order to minimize the outcoming liquid temperature error. The output from the slave controller is fed into the master controller and used to adjust the cool water valve accordingly. That's all from me. Thank you.
Assalamualaikum. My name is Nur Syazwani binti Abdul Rahman. I will explain in part of distillation column. First is description the process to the equipment. Usually in a basic distillation column, a feed stream enters in the middle of the column and have two stream leaves, which are one at the top and one at the bottom. Distillation is the process of separating the component or substance from a liquid mixture by using selective boiling and condensation. Separation is achieved by controlling the column temperature and pressure profile to take advantage of difference in the relative volatility of the mixture component and therefore tendency to change phase. The lower point components evaporate and travel up the column to form the top product, and the higher boiling point component condense and traveling down the column to form the bottom product. Next is process to the safety, legal, and environment issue. From safety point of view, there are many safety precautions they need to know when using distillation column. The safety precautions for distillation column are allow sufficient space to work in, means that your distillation area should be well lit, clean and well ventilated to prevent the accumulation of alcoholic vapors. Second is when working with flammable liquid such as ethanol, care should be taken to eliminate any fire hazard. Keep a fire extinguisher handy and collect the distillate securely so the risk of spilling it is reduced. Third is perform a cleaning distillation first. Lastly is read basic distillation rules for some guidelines before performing a distillation. There are three main of control objectives of column can be stated. First is to set stable condition for column operation. Second, to regulate condition in the column so that the products always meet the required specification. Lastly, to achieve the above objective most efficiently, as example by maximizing product yield and minimizing energy consumption. Then there are two manipulated variables can use in distillation column. First is flow controller. Flow controller are used to control the flow rates of the product, the reflux and the heating medium used in the reboiler. Second is level controller. Level controller are used to maintain the level in the accumulator, the reboiler and the intermediate accumulator of stack column. The major type of disturbances encountered in distillation column are feed composition upset. Change in the feed composition represent the most significant upset with which a distillation control system must deal on a continuous basis. A feed composition change shift the composition profile to the column, resulting in large upset in the product composition. Most industrial columns do not have a feed composition analyzer. Therefore, feed composition upset usually appear as unmeasured disturbances. Second is subcool reflux change. When a thunder shower passes over a plant, the reflux temperature for the column can drop sharply. Columns that use fin fan coolers as a overhead condenser are particularly susceptible to rapid change in ambient condition. If internal reflux control is not applied, severe upset in the operation of the column result because of major shift in the composition profile of the column. When internal reflux control is correctly applied, the impact of a thunderstorm on column operation can be effectively eliminate. For distillation column, the type of controller is feed-forward controller. A feed-forward controller can avoid the slowness of the feedback control. Process variables such as pressure, level, flow, and temperature are interrelated, and so one variable may affect another as a disturbance in the process. Feed-forward system measure important disturbance variable and take corrective action before they upset the process. Here, the set point is fixed in the feed-forward controller. The feed-forward controller can determine the needed change in the manipulated variable so that when the effect of the disturbance is combined with the effect of the change in the manipulated variable, there will be no change in the control variable at all. So this is control scheme and PNID diagram. The feed into the column may be vapor, liquid, or mixture, but most commonly a liquid. Its composition is usually variable. Liquid in the bottom of the column is boiled out through the column, and vapor leaving the top is condensed and returned as reflux. The product flow must equal the feed flow, or the process will not operate very long. So the liquid level in the bottom of the column and the liquid level in the reflux accumulator are controlled by manipulating product flows, or sometimes by manipulating head to the reboiler or reflux to the column. Flow controller are used in this column to control the flow rates of the product, the reflux, and the heating medium used in the reboiler. And their set points are determined by the various level and composition controller. Level controller are also used to maintain the level in the accumulator and in the reboiler.